Okay, so welcome to BinarX Student Payload Development Program Week 37, where we're going to go through your payload development kits, which are now getting delivered to each and every one of your schools. So we're going to go over all the parts that come in the kit. This you may have seen before in your payload guide. This is the Binar Payload Development Kit. So you've got the BinarX microboard, the spacecraft emulator for the flight computer, and your payload boards, which you'll remember from last term from your critical design review. So let's get started and go through all the bits. Okay, so today we are going to walk through all the hardware that comes in your BinarX payload development kit, including the spacecraft emulator, which you're going to use to test out your payloads. So today I'm just going to take you through all the parts that are going to come in that kit. Then we're going to use the test points that are on the board to check that the voltages are all good before you start doing your payload, and just an explanation of the components that you need to know. We're not going to go over every single part of the board, just the parts that you're going to need. So this is the board. This is where your microcontroller board goes and your payload board. You can see this way to space, and there's this little connector here, but we're going to supply these to you already installed with the screws, because the screws are easy to lose, and this is what you'll be getting. This is what it'll look like. So I'll just go over the parts of this board. We have the BinarX Payload Development Program microcontroller board. So this is your Arduino, as it were. So there's the chip. And on there you have some test points, which we'll get into in a minute. This is the Binar Space Flight Computer emulator. So this is what's going to talk to your payload, but we don't need that at first, but just know that's what that is there. And then this ribbon cable is the one that connects your payload microcontroller board to the flight computer. You can see those tracers, but you don't need to change any of that. This version of the board has 3 modes. So if you just want to test your payload, which is what we're going to do today, you've got an off switch, the payload's off. On switch, the payload's on. Oh, it's a very satisfying switch. And if you want to run it, which we won't do today, via the flight computer, you would put it to auto. And we'll talk about that in another week. That's the button that you use to run your payload if that's the case. But if we just want it to be on, that's great. So I'll turn it off for now. And then you've got a 9-volt barrel jack connector here. So you will get this. So if we take that out of the box, then you get something that looks like this. Which yeah, so you're going to have your power supply. So that's going to go in over here. You have your debugging cable, which is what you use to connect this little connector here. Connects onto the debugger here. That's how you're going to send code to your payload, to your microboard. You've got a USB A to C cable. Now you have to make sure you've got the one that connects data. So that actually connects. We'll just pop it onto, well, we'll do that afterwards. That's going to connect to your debugger. You won't need this for today, but it's a USB micro to A. Now you'll already have these in your Bintro kits, but we've given you a longer one just to make it a little easier. That will connect up to the emulator, but we don't need that today. You just know that it's there and don't lose it. And then you're going to have your payload hat board. So you'll recognize this board from your critical design review last term when you designed your circuit to go onto these boards and these connectors. It connects to the microboard via this little press connector here. Please be gentle with it. But the idea is you can put it in there, and via that connector, that's going to connect through to the microcontroller and into the flight computer eventually. All right, so those click together like that. Now what we've supplied to you for this term, so that you can do your testing, you'll have one that's actually got these lovely little header pins soldered onto it, so you can use jumper leads to put those on, and then if that connects on there, and we won't show you this week, but you'll be able to breadboard out on a breadboard, and then just use your jumper leads to connect in here to the appropriate pins, and then you can do all your testing before you solder onto your board. So now that that's together, I'll just go over the other connections and how we're going to make sure before we start each day to set up and make sure that our payload's giving us the right amount of power and that all the connections are good. So what I'll do is I'll take my 9-volt that you saw earlier. I'll get the 9-volt DC power adapter, and we're going to just plug that right in there. Gentle. Great. So we're still off. And then what we're going to want to do is we are going to power on at the wall. So I'm off camera, but I'm going to switch on at the wall. Turn on my 9-volt. Now we should be getting, we're going to take our trusty multimeter. We're going to turn it to DC power, which mine already is, so hopefully it's not out of batteries. Oh, there we go. And you see we've got these test points on our board, and we've also got them, actually I'll pop this off. We've also got them on here. So this is how we're going to know if we're getting the right amount of voltage. So if it's a 9-volt power supply, we're going to be expecting to be getting 9 volt as our VBAT. So always start with ground. So you can see we've got ground there. So you can see that. We're going to start there. And then we're going to say test point 1. And that's giving us 9.23 volts, which is great. That's exactly what we want. Now, if we do the same on here and we start with ground and VBAT, we're probably not going to get much at all because, yeah, so there's a little bit of noise on there. We haven't switched our payload on, so that's what we're going to do right here. So we're going to go ahead and switch it on. Oh, and we can see that payload power, we've got a little LED there as well, which is great. And then again, we're going to go there, ground and VBAT. Like playing operation, and 9.23 volts, which is great. And you'll also see, if you see here, we've got a 3v3 power supply, which corresponds to the 3v3 pin on your payload board, which we'll just grab here. So you can see on there, you've got 3v3 up this end. We want to make sure that that's the right amount of power. And we're going to test this before we start each day, just to make sure that something hasn't gone funny and that we're not going to cook our payload components as we try to prototype it. So now that our payload is powered on using the on switch, I'm going to go ground and we're going to check 3v3. And there we go. Perfection. So that is all we want to do for today. I'll show you quickly what these other components are, and then we can get started next week with doing an LED circuit on a breadboard and programming our microcontroller. So going back, I'm going to switch it to see if you go to on or to auto. It's going to say it's switched off as well because it's only going to run when this is all connected. It's not connected today. I'm going to switch that off because we don't need it connected for now. This is your debugger. So it connects one end via USB-C. There, and the other end into the computer you're using to program your code, but we're not programming code today. This is just for later. And then the other bit, just very gently, you gotta line it up in the middle and push down and there. So that's your connection to program your payload when it comes to that. The other thing that you're going to want to know is this cable here, which is the micro, which is not my favorite connector. I find it really delicate, to USB-A. That goes into that connector there, or upside down. There we are, and then that would go into your computer as well, but you won't need to be doing as much with that. The other components on this board that you should know about, this reset button here will reset the flight computer. This button here, if you're in auto mode, will run your payload, turn it on, wait for the data, receive data, send data over, whatever it's listening on. That's going to be for later in the track when we're testing our flight software or our payload software. And then this resets your debugger here if you ever need to do that. But that is all we're going to cover for today. If you have any questions, please email us at binarx@curtin.edu.au. But it's been great getting to this point, and please do take care of these. These are yours to keep, but if something breaks, let us know. That's all right. But it may be a little while before we can get another one, so please just do take care of these. They are delicate, static electricity. Keep them dry. Keep them in your payload boxes, and that'll be great. All right, everyone, good luck, and we'll see you all next week.